In this video, we're going to look at the gradient graphs of tangent functions. So starting off with f of x equals tan x, we're going to start off and just have a look before I run the animation what's going to happen. Now, if you look at the tangent function, then we'll see that the gradient of the tangent function, no matter where you are, is always going to be positive. So when we draw the gradient graph, we know that there's not going to be any values below the x-axis, okay, because they would represent negative gradients, and there is no points of negative gradient on the tangent function. Another thing we have to consider is for a function to have a gradient, then it needs to be continuous and smooth. Now this is not a continuous function because we have points that are undefined at pi on 2, 3 pi on 2, etc., 5 pi on 2. So we have asymptotes at x equals pi on 2, x equals 3 pi on 2, etc. Therefore, because it's not a continuous function at these x values, then you're not going to have a gradient corresponding to these x values. So now if we run the animation here, we'll see a starting point of 0 here, the gradient's 1. And what's going to happen, you see here, as we go from left to right, is the gradient's going to increase rapidly as we go further to the right, and we'll see that here. Okay, so you see you got a gradual change in the gradient at this point there, and then as we go here, the gradient just is going to shoot right up there, you see. We're going to have a really steep gradient at this point here, and then it's going to level off, and it's going to go towards, you have a gradient at 1 again. And then as we go to the right, you see the gradient's increasing, and the gradient gets steeper and steeper in the tangent function. And again, at this point here, real steep gradient coming down, it's going to get to 1 again at 2 pi, and then the gradient's going to increase as we go from left to right. When you look at the gradient graph here, it might not be a graph that you recognize, but what this graph actually is it's actually 1 over cos squared x. So when you differentiate tan x, the derivative is 1 over cos squared x. So if we look for the rule for when we find the derivative of y equals tan x, the derivative is actually going to be 1 over cos squared x. So looking at a general rule, if we have y equals tan f of x, then the derivative dy by dx is going to be f dash x over cos squared f of x. Now you might also see this rule written differently. So what we have with the trigonometric functions is you have reciprocal functions of them. So the reciprocal of cos x is 1 over cos x. And the name given to that would be sec. So sec x is 1 over cos x. So therefore 1 over cos squared x can be written as sec squared x. So another way of writing the derivative is you can write y equals tan f of x. The derivative dy by dx would therefore equal f dash x sec squared f of x.